A very good day to everybody. So in Germany, it's still very early in the morning, but I see we have again people from all over the world attending this webinar. So yes, I'm very happy about that. Today we have a webinar about secure edge compensation, and there's a little subtitle there, including horns. So this is a new development. We will talk about that later. It is the 18th of June, like you can see, and we will now start. So first of all, we have a small explanation how the webinar actually works. So what are you supposed to do? What am I supposed to do? This kind of stuff. So, and probably you noticed that you can talk a lot and I won't hear you. So all attendees are actually muted, but still you can communicate with us. There is on the right side of your screen, there is a questions button. And if you press this, you can talk. And then actually on the other side of this questions button, you don't see her, but she is definitely there, is my lovely colleague, Miss Sylvia Liemer. You can also see down there in the sheet that she is there, but actually she can not only hear you, she can only talk, also talk. Sylvia, are you there?
Yes, I'm there. Good day to all attendees. I will try to answer your questions during the webinar, and I filter them so we have a list of questions we can answer at the end of the live demonstration, and that will be the questions most interesting for the whole audience. So now I'm staying silently in the background and only come back after the live demonstration.
That is, unless I maybe forget half of my sentences, you can also add some if you like. Okay.
I will jump in then.
Yeah. So actually, Sylvia already did also the next points. The answers are at the end of the webinar, and actually you will also get a copy of the video or from the webinar afterwards, and that can be downloaded after the webinar as well, not before. So the content of the webinar is a short UCAMCO introduction first, and it will be very short. And then an introduction to secure edge compensation. What is it? And then we go directly to the live demonstration. And afterwards, the questions and answers we already talked about. Well, not about the questions and the answers itself, obviously. So first about UCAMCO. It says here UCAMCO serves the global PCB industry. This is very true. It's not only serves the global PCB industry, we are also a global company. We have offices all over the world. So it goes from Japan to America and everything in between. That would be probably Hawaii. What are our products that we have? Well, we have laser photoplotters and DIs, where they are best-in-class performance and the long-time reliability and constant evolution. Well, the ones of you who have our machines will know. Then this is, of course, what we are more talking about today, the manufacturing software like Integrator UCAMX. And True Edge compensation is actually part of UCAMX. And we have also new web-based software like IMCAM and Communicator. And of course, our software comes with a lot of machines. So we have electrical testers, AOI machines, and well, you can find it at more places than you think. And well, one of the most known products from us is Gerber. I mean, we own the Gerber format. So actually all the developments like Gerber X2, X3, or the job format, they are also coming from us. So in that case, I think most people have have heard of us. So now we come to the secure edge compensation. I mean, you see already here some very nice examples what it actually does, and I can also hear you now like, wow, what's it doing there? And I can see even some original copper, but we'll talk about that later and all the options that you have. So first, maybe we talk a little bit why you want to compensate your copper image. Because actually, I mean, of course, your customer wants to have a certain width of your tracks and a certain size of your pads. It is actually, and the etching is not going down straight below. I mean, if you see this little picture to the right side, it almost looks like a real, well, what you get from your laboratory. If you say, okay, make me a picture of this these two tracks, then you can actually see almost this kind of image. And actually, this is also what happens if you're etching, you know. So if you have the etchant, it will run through your between your tracks and between your, and actually it is well, it is predictable, but it's more complicated than you think, you know. So, and because you are etching away a little bit of your copper, you have to compensate. I mean, not only, I mean, you etch away a lot of copper, obviously, but also from the width of your tracks. So that would be the walls. You know, they were getting etched away a little bit because you also have here a little feet on the bottom side, a little foot, I mean. So then actually, so that's why you compensate your etching, your image. So, and also the shape, like how the image looks like, it influences how the etch, the result of the etching afterwards will look. So the edge compensation that we are introducing here, the secure edge compensation, it can actually apply different compensation factors to different shapes. I mean, this is a picture that you see over here. We have pads that get 10 microns, which is only a little bit that you can see over here. The SMDs get a little more, 25 microns. The tracks get quite a bit more, 40 microns, and the regions, they have 0 microns. So there's a possibility to say what you, which features should get which spread. Okay, and this is very obvious to see in the window, the secure edge compensation window, where we have the different spreads on the different feature types here on the top left. But what we of course also have is that you can define between the different features what kind of clearance do I want to have. So I can define between pad to pad, pad to SMD, pad to track, pad to region, you know. So, and I can do this for all combinations that I have. I can define different clearances that I want to have. So actually what we are going to do with the secure edge, we are going to apply the spread, and then we are going to check where do we have clearances, so not enough clearance, and we will reinstate this clearance afterwards. We will always take care that the clearance is there. So this is actually what it says on the third line: the full spread where possible, and only local corrections to maintain the clearance. And like it says over here, it's fully automatic. A big feature is that you can actually use parameter sets. So you can very easily say, I want to apply my etching for copper of 18 microns or 35 microns or 70 microns. So you just choose and you say apply, and then you're done. Well, it starts to calculate, and after that you're done. Okay. So, and what we also will see, because it's actually very useful, that the original data will be saved as a backup, and you can use it as an on-screen reference. So that makes my demonstration a lot easier, I can tell you. So, and it's of course suitable for all the PCB types. Now, this is a new development, the horn section. So it's kind of, yeah, well, it's something from a classical concert or something like this, the horn section, but it doesn't matter so much. In this case, it's something else. Actually, it says also over here, the etchant around the corners is around the corners of all copper. It etches away the corners of all copper objects. So all the copper objects will have that the corners are being etched away more or less a little bit. And this little bit is, of course, for very small SMD pads, it is a big problem. So actually what you see in the background over here, the little green picture, this is a very small SMD pad. And this was, initially, it was a square pad, and you can see that the corners are actually completely gone. There's no corners anymore. It's kind of rounded, a rounded feature now, you know. So, and actually what you can do is add little corners that you can see over here. So horns. And if you use these horns, then the result will actually be a nice and square SMD pad. So this is a new development. We will also have a small demonstration of this. Here's just a sheet to say, okay, what are we doing? So we are adding these horns to the critical SMD corners, okay, and so what we're actually doing there, I mean, you see over here the easy to use interface, the horns, and actually what you do over there is that you say, okay, I have a certain small pad. I mean, so you can actually set a maximum width, which in normal circumstances would be like maybe 300 microns, something like this. And then you can, for those pads, and for those SMD pads only, you can define a new spread. So this is one that's actually not the spread that we already before defined for the SMD pads, but this is a spread only for the pads that are small. Okay, so you can add a dedicated spread for this one. And you define an overlap and an extend, where the overlap, if the blue thing is the SMD pad, is this large area over here, and the extension is actually the C part. So how far does the corner go out? Okay. Now, if this horn is created, then afterwards we still do a local shaving to guarantee clearance to any next objects that are lying next to it. Again, this is fully automatic. So one last question remains before we start with our demonstration. This is why not do it manually? Because of course, a lot of people are now also doing their edge compensating. I mean, you have to. I mean, and then as they say, okay, we just make everything a little bit thicker and it will be fine. You know, so and this might be the case if you have easy to make boards, but most of the time the boards, they are getting more dense, they're getting more complicated, and it will just, well, it's not enough anymore, you know. So, and if you want to do what the Secure Edge does manually, then actually you should follow all these steps, you know, the select SMDs, thicken all other pads, thicken tracks, thicken regions, thicken clearance, DRC check, then repairing what is going on. And well, Sylvia did a try and she said, well, I need about 35 minutes for the layer, so it's about 2 hours for the whole job, you know. So that's quite quite a lot, I would say. And we will see if we can do it quicker and thus cheaper with the Secure Edge compensation module. Oh, wait for it, too fast. Okay, so now we will have the live demo. So therefore we have a UCamX, and the UCamX, we can load a job like this one. Okay. So over here, well, I mean, this is just, of course, the standard UCam. I put my Secure Edge compensation on a toolbar. Okay, so I can just open it like that. That's the most easy way. I mean, you can, of course, also open it over the menu. That's also a possibility. So And what we actually see now, it's already the window that we talked about a little bit during the presentation. So we have our spreads over here and we have our clearances over here. And just for the curious ones that are now listening, it is maybe interesting if I, of course, do my spread over 30 microns and my clearance of 150, I would need to have 210 microns clearance between my features. And I have just now, I mean, I created here a little DRC check. So this is a standard DRC. It has nothing to do directly with the secure edge, but just to show that we have a 210 microns here. And if I will check this data on 210 microns, it will actually say, okay, I have 1000 track. Over here, track to track. I have 150 pad to pad to track 50. So I have 1200 errors in total. And some of you might say, yeah, well, here between the pads, I do shave my pad and I'm fine, you know. But if I'm going a little bit and have a look through my the issues that I have on my PCB, you can actually see that I have everywhere with my copper planes, I have issues. I have, well, in this case, this layer is actually quite fine. That's good. It's actually there to show a few different things. And this is again one with a lot of tracks where I have so many clearance issues that it's actually difficult to, well, I cannot not do this in half an hour. I mean, Sylvia seems to be able to, but for me, it would take longer. Okay. So, and obviously, if you are seeing 1200 errors and you have to fix this all, I already can imagine your face, you know. I mean, I took a picture and it will probably look something like this. I mean, it does not make you happy. And so, and afterwards, if you then fix this after 2 until 4 hours of work, and you go to your boss and you say to your boss, I took just 4 hours to get this thing done. Look what I did. And am I the best employee you have? Then actually probably somebody will not be happy, you know? So, and this is where we come in then. And we can say, okay, maybe we can make everybody happy. And that's actually what we are going to see now. Well, at least I hope. I think so. Like this. I will do the complete job. Okay. And I say I want to have my spread. I want to have my clearances, like over here. I have also here my section with horns. So I will, all the pads smaller than 0.5 millimeter will get them. And what I will, in the meantime, I will just press apply so it can, because it has to do, of course, some calculations. So it will now start here performing secure edge on the bottom Bautile side. It's German, so the component side, and it's already done on that one, you know. So it goes now on with layer 2. Anyway, in the meantime, I can tell you a little bit about this. We have something here that says minimum copper width is 100 micron, which assures you that actually afterwards, if you run the edge compensation, that every copper on your PCB will have at least 100 micron width. That's of course a very useful feature. It's also, sorry about that. It's also quite easy to see afterwards where Secure Edge does this. Okay, and I see, by the way, that I obviously I forget to set a switch, because actually we have something here. I was going to talk about them and also to show what they are doing, but this is not the easiest way to show what they're doing if they're not switched on. Now, but I can of course use this, that I forget this to tell something else. I have now already, it's done. It's taking a minute. It's not that long. Okay, so it's don't worry. I will not keep you here for the next 2 hours. I will just press an undo button. Okay, and actually what I say, I will tick this on, and again I will use my apply. So now I can talk a little bit again. We have here a process, same net clearance. process same net clearance. So actually, if I have something like peelables, it will take care that it also has the 150 micron clearance between the pad, so and the track. But also, of course, if same net is also very important if I have coils. So if I have a coil somewhere on my PCB, this is actually a very useful feature. So it actually also allows you to get a nice width for your coil as well. Okay, then we have something like check missing original copper, which is you can say, well, you saw it already a little bit in the picture before. We can also touch the original copper, but of course you get warned about this. I mean, that's logical. So it will, so it will then still, of course, you can afterwards, after you get notified, you can of course still change this. You know, it's very easy. Then we have the backup of the source layer, which is also a very useful feature, as we will see later on. And we have the shift to region. Well, this shift to region, actually what it does, you see already a region here on the left side, a little copper pore. And actually this copper is normally, it's not that important because it's just a plane and people just come with their, and they just throw a bunch of copper between the tracks and the pads, and nobody is thinking that you need to do your edge compensation, you know. And what it actually now does is that it says, okay, I prioritize my pads, SMDs, and tracks over the region. It's done, by the way, now. So I actually get a message that there's no errors. It does a net compare. Okay, so we're good, I would say. So I click this away, then we can see this again. So we have the shift to region. And and actually what it will do is that it takes away a little bit of the original copper of the copper pores to make room space for the tracks that I have. Okay. So now what are we seeing here? I will just show you that we have now our reference layers. Okay, maybe first of all, I see that I have some selections, and these selections that I have on the board, and I have them actually on these 3 layers. You can see this over here. Are the the positions where the minimum copper width has been too low. So I have here, for example, and if I zoom in a little bit, I can do it like this. Okay, you can see that here we have some extra copper. If I click on the original layer, you will now see what happened. You can see already quite a lot, by the way. You can see that the tracks, you know, they got their copper, their compensation. The pads got the compensations. The regions did not get any compensation. Okay, but you can also see that here that we had the green area or the sand color area, that it was too small and that we actually put on a little extra copper here. So, and it ensures that we have then our 100 micron. Now, these situations you will find on all the layers that we also have down here. So we can we probably do not need to show them all. We will come to every layer anyway. But if I click over here, you can see also that we have some tracks, you know, that there's some copper over here that was not wide enough. So there's different situations that where I have this minimum copper width that was not enough. So let's start, but let's start down here and then let's work our way up, shall we? So we are going here, and you already can see a little bit that we have kind of a lot of green and sandy stuff, but of course you cannot see really well what's going on here. So let me just zoom in on a certain position, like over here, for example. And here you see, of course, that we have all the pads. They are they are nicely compensated, and you see then between the tracks that we have less compensation. Okay, here's one there's a little more, but actually the distance between the two was bigger, you know. So everywhere over here that you can see over here, as the copper has been nicely moved away, and then you can say, oh, but now I don't have my 30 micron copper over here, you know, so it's over here but not over here, so it's not okay. But if you remember the picture that we had before in the presentation, actually this etchant that we are having, it is flowing a lot on these big areas, you know. So here you have a lot of well, turmoil going on, and so, and actually this etching here, there will be more etching done on this side than on this side, because here the etchant cannot flow that fast, you know. So actually what we're doing here is actually then in the end giving you exactly the result you need, you know. So that's actually what is going on in this location over here. And actually, so this is happening here all over the board. I can zoom any corner if you like, but it's, you know, so the room is never enough, like over here, of, you know. So it's, this is what's, so on this layer what is going on. Now let's see on layer number 3 what is going on. So I will also do a total view, and I will again put on the third layer, and over here you see all little crosses. Okay, so and these crosses that we have over here, if I zoom in on one of those, like over here, check, okay, you see that we had a thermal in the copper area, and this thermal in the copper area, the connections, they were not wide enough. Actually, I mean, I measured them, they are only 80 microns, and we put on a new track so that actually the thermals have now 100 microns. Okay, so that's actually quite useful, and so it's working very fine on plane layers as well. So that's actually what is to see on this layer. Let's say of course the etching of the regions was 0, so there's no copper being extra copper for the regions. So so much to see on this layer furthermore, but we can go to the next one, like this one. And here on this layer we actually can see now what is being meant with the shift to region option. Okay, so the shift to region option, now let's zoom in somewhere over here, for example. You can actually see that all the tracks that move here, that they cut away some of the original regions, because like I already said, this copper that you have over here, it is normally only there to, yeah, well, to fill. It's a filling, and actually you don't need it. Also, if of course we would, it also takes care that if we don't have enough space, now I need to see, because I think there was still something that I then missed on this layer. I now remember, like over here, it has to do with the fact that if I do it like this, you can see it much better. And if I, for example, look over here, you can also see, you know, I mean, we don't have enough copper here. So also this will be fixed, these kind of situations. Okay. So we go back to layer 2, where, I mean, on the exact same position, you can already very easily see what's going on here. You know, so this is actually the shift to region option. If you would say keep original copper of the region if possible, then actually, of course, it would be taking away some of the copper over here. I mean, from the track again, because then the space would not be big enough. You know, so it would keep the original copper. So there's an option for you if you want this or not. So, and now we are going to the top layer, and the top layer, we are also seeing something else on the top layer, actually. So if I zoom in, well, I think we can take any location. this one, for example, you can see that we have all the pads that are smaller than 0.5. They are now having horns. Okay, so and also, like we also said in the presentation, we have, for example, here where the clearance would not be enough, we shave away the horns. And like I explained before, this is not a big thing because actually over here it's very dense and etching will, so you will probably not, the corner will not be etched that much as other corners that are over here. So here the etching will be more. So in the end, your image will look very fine. And like I said, we had so this whole job that we did now, it took 1 minute for us to process it, and in the end, what you, of course, the result is that your etching process will be much more reliable. So either what you can do is that you can say, okay, but now if with this technology, I don't need to make only boards with 200 micron clearance. I can also now make boards with maybe 100 micron, and I use this one to free up space wherever I need it, you know. And obviously, I mean, 100 microns is maybe, but we'll can also talk about 80 microns, and then you can go down maybe to 70 microns, you know. So this is a way where you can either you process more dense boards, which is good because then you will get more jobs that you can from your customers, and your process will be more reliable. So in two ways, it's actually very good. So Sylvia, do we have questions? Because I think we are through. I mean, I think I talked about almost everything. Maybe I forgot something, but then we'll hear about it.
I think so, yes. And yes, we have a lot of questions. Some I already have answered. And I have some which maybe are interesting for a wider audience. So let us start with one. Does the SEC need a markup before running? I think this is coming from someone who's using our other tools where we need the markup assistant and so on.
Yeah. So, well, well, actually, it's kind of what to say. No, so you don't need to do a markup. It's looking at pads, SMDs, tracks, and regions. I mean, the regions, it's is of course a certain aperture. The tracks, they are draws. SMDs are boxes or rectangles, and pads are round, so are circular pads. You know, so that's the SMD is the SMD. The markup is already inherent in the data. So there's no need to do a markup.
That's good. Another one would be based on the flashes. Which pads are getting horned?
Which pads? Well, first of all, we have, of course, our width. Okay, so and the width is then taken and checked against every box and rectangle that there is in the data. So those pads that will then fall into these criteria will get horns.
Okay. Are rectangular or box-shaped pads with drills still be considered SMD and get the spread for SMD?
Well, yes, they all, because it's running on all the boxes and it doesn't check if a drill is passing through or not. But I think that normally you will have very small pads, so you will have 250 micron pads. So, and I don't know if you want to do a 0.7 drill on a 250 micron pads. So I think that normally if there would be a drill hole, it's probably something like a laser drill, and they are copper filled normally anyway. So, and then you would need horns anyway on such a pad, you know. So I mean, so yes, it will do those pads as well, but in practical things, I think it's actually a good thing that it happens.
Thank you. So what if the SMDs are coming in as flashes, but as complex pads?
Well, complex pads, well, they will get, of course, they will be handled just as SMD. So they get the spread of the SMD, but they will not get any horns. I mean, the horns will, this is also, again, something what you can then see in your aperture manager. A complex is not a rectangle or a box. If you want to have this, you need to transform them into rectangles or boxes.
Okay. And another interesting one would be, are there other security measurements involved to make sure the data is still valid? I think we have seen.
Security measures. So what we have, of course, is we generate a netlist before and after. You also saw that when I run the secure edge compensation, that a big window came on top of here, like saying, okay, I don't have any errors. This was because we did the net compare. So in the end, you can be sure that you can be sure of two things: that your net is okay, and of course that all your clearances that you set are in place. So that's what you can be sure of.
Mm-hmm. Okay. Is there a possibility to mark some elements to not be modified? Oh, that would be...
Not be modified. So that would be something like maybe impedance tracks or something like this. That you can, then you would say, okay, I want to have this on my on everywhere, but not on my impedance tracks. Yes, you can do this. What you, for example, can do, well, let's see. By the way, let's see something over here. I mean, here we have something, okay, where we have a little track, and you can also see that actually the clearance was not enough. So, okay, we set this without clearance, but now, for example, you want to say this track is not, should not get any compensation. Okay, so what I will do is I undo the compensation of this layer. Maybe in this case, it's also interesting to tell that we have an undo button, and actually this undo button will, and I press it now, it will remove all your edge compensation data. And this undo button will also work a year after, and maybe also 2 years after you did your compensation. So, which actually means that if I want to produce the board, it was produced, for example, in 17 micron thickness, copper thickness, and I want to have it in 35, I can just undo and then use a different spread. And well, but this is not the copper thickness now, this is something else. This is the kind of the clearance or whatever. So, and I can just reapply then a new spread. So that's actually, I think, a very good thing. So even after a year, you can just undo all your copper. You can redo it with different values. So that's quite good. So that's what I did now on this layer. I did an undo, so everything is back to the original state. And what I want to do now is, let me think, it was the impedance tracks. So this track is an impedance track, okay? And what I actually can do is I can say, okay, I select this track, like over here. And what I then can do is, well, and I do, of course, I do a little trick. I'm doing the demo here. I can use my right mouse button, for example, and I say, okay, I want to exclude this from my from my spreading, what I did now. So I undo my spreading, and now this layer I will redo my compensation. And in the end, when it's done, then you will see, well, we have to wait a little bit. So now it's still doing a net compare. Okay, there we are. So, and you see that this track is now exactly the same as the one before. So if I put the original layer, where is it now? Ah, it was not done. Okay, so my net compare is still okay. And now my original layer is also there. So, and now you can see that this track is still there. You can also see that it is now a different shaving that's done here. So it's not the same anymore. But now, of course, the clearance is still there. We still have the required clearance here. Okay. So,
thank you.
Yeah, so we'll keep it by the. Yeah, I think that was enough answer.
I think so, yes. Okay, we have some more questions on the list, and we will answer them afterwards via email. But now I think we should go through our summary and coming to an end because our time is nearly over.
Okay. Maybe also here, I mean, it's really nice to see this, I mean, over here you see where the horns actually, how they get also the clearance everywhere. The clearance is there, so if it's really looking very nice, if you ask me. Okay, so let's get back to the end of the presentation, and I promise it will not be too long. So the benefits is actually that you can pass your end customer inspection procedure with dedicated copper spread for SMDs and pads. So the SMDs and the pads will have the correct size in the end in your quality department. The same goes for tracks, and especially also the special tracks like impedance or coils. If they have to have a very specific value, then you can also set the values extra for your tracks. The copper regions, what is the third point over here, is it can be, so the etching can be simplified a lot because you can make space for your tracks and pads, what we also saw. You can exclude text, logos, impedance traces for compensation. That was the last example that we saw. Slash setup time, that sounds very good, using parameter sets based on copper thickness or customer specifications, what we also say. You can just saw, you don't need to punch in all the values, you just have your 18 micron data set and everything will work fine. Perfect retracting of modifications made by SEC, saving them with the job data. That's also what I said. 2 years later, you can do your secure etch for a different copper thickness. So in the end, you will have higher yields, so you can, because the etching process gets better, you can make, well, the process does stay the same for sure, but at least the data that you give it, so the copper, it will have a higher yield in the end. Then you can also fabricate denser geometries. So, and don't underestimate that you can do more now than you can do before. And so in the end, you can improve your etch results, and it saves you money, and it will increase your quality. No, the one of your board. So that was the webinar. Thank you very much for attending. If you want to check this software out, I mean, you can just ask for a trial version at sales@ucamco.com. So I think there are still some answers, Sylvia, that we didn't answer. There will be more for sure.
Yes, of course.
So Okay, so you will get all an email with the answer that you that you need. We're also looking for any feedback. I mean, so you can say, "Hey, great job," but on the other hand, you can also, well, your feedback could also be questions, or it could also be like the topics of seminars that you want to see. So if you want to see, like, okay, how is Jucamco doing this, or please send us topics, and we will see if we can also turn this into a webinar. And of course, everybody who is here now will also get informed the next time for new webinars. So thank you very much, everybody. Have a very nice day and see you the next time.
Bye-bye.